So the present value of cooperation is pi m by 2 upon into 1 upon 1 minus delta. This is how much you value the stream of earnings from cooperation over the entire lifetime. If you cheat, how much you get? Pi m today and nothing thereafter.
Yeah.
So the present value of cheating is pi m. Cooperation will be sustained only if this is greater than pi m. Right? Only if this is greater than pi m. Cooperation will be sustained only if this is greater than pi m. Right? If you cancel pi m from both sides, okay, and solve, you will get this implies that del has to be less than or equal to half. Del has to be less than equal to half. That is, both the players have to be sufficiently patient. Both the players have to value future gains sufficiently highly relative to present gains. Right? So when will cooperation be sustained in this market? Only if the market is an infinitely long-lived market. If there is a trigger strategy, that there is a punishment rule, right, which says that if you cheat, we'll set price equal to marginal cost for the rest of the time period, rest of the duration of the market. And finally, if the discount rates for individuals are sufficiently high. If all the individuals are sufficient. Okay? So now, think of a situation where the first player's discount rate is 0.6 and the second player's discount rate is 0.53. The first player's discount rate, suppose the discount rate in this market, okay, the discount rate in this market for both the players is 0.6 and 0.5, right? Okay? So will cooperation be sustained? Yes, because the condition of sustaining cooperation is the discount rate should be greater than or equal to half. Okay? Now suppose one more person comes into the market. One more person comes into the market. How will the situation change? The rules remain the same. Then the first impact will be each one will get 1/3 of the market profits.
Profit will
So
go at
this will
3.
become like this. What each person gets, right? So this will be like this, okay, right? So this will be 3. So this will become, if you solve this, you require delta to be greater than or equal to 2 by 3. Now, the folks who were patient enough when there were two markets are now not sufficiently patient for cooperation to be sustained. And the market will collapse. You see what has happened when the third player has come in, the benefits of cooperation are now, they're half the profits, now they're 1/3 of the profits for each person. So the benefits from cooperation go down, but the benefits from cheating remain the same. And so as the number of players increases, the chances that cooperation will be sustained goes down. Okay, so a market which was oligopolistic, when there were two players and when cooperation was a Nash equilibrium which could Nash equilibrium, will suddenly cease to be a cooperative market just because an additional player has come in, will cease to be an oligopolistic market and prices will rapidly fall to marginal cost. Everybody will cheat, prices will be equal to 100 throughout the game. Right, so that is how sensitive markets can be to the number of players. Especially markets of this kind, are sensitive to the number of players. And therefore, fisherwomen or people who are selling things on footpaths, etc. are very, very sensitive to who are the new people who are coming here and selling things. Right? Therefore, there is a lot of turf war in the market for selling goods which are essentially identical. Right? Okay? Sure.
I think understand why delta has to change.
Then because what is the solution now? Pi m by 3 into 1 upon 1 minus delta has to be greater than pi m. So if you solve this, the condition for delta will be greater than, that delta has to be greater than 2 by 3. If you cancel this out, this becomes 1, right? So 3, so if you solve this, the answer will be that delta has to be greater or equal to 2 by 3. Right? Sure? So that is why cooperation in markets of the kind that we have been discussing is extremely hard to sustain as a Nash equilibrium. So the lessons for today are: one, you must know what is a game, what is a dominant strategy, what's a dominant strategy equilibrium, what is a Nash equilibrium, what is the difference between a Nash equilibrium and a dominant strategy equilibrium, right? And you have to have some sense of what is backward induction, right? You also have to know what is Bertrand's paradox. So at the end of this video, once you hear this video, you can answer these questions, then you have sort of learned this lecture properly. Okay? So thank you very much.
So how to spell Bertrand's paradox?
Bertrand, Bertrand's paradox.